everybody has the linear algebra, I didn't give it a name, up in front of them, the links that I sent you in the Piazza. Anybody has any problem seeing something that looks like this in front of you? Let's do a quick vote. How many people have it open? 16 people, 17. We have 2 yes, 3 yes. Yes. I have it. Thanks. Okay, let's wait for a few of the others. Ash, Travel, Jesus, Cole, Maxton, Jake. Okay, and let us start. So what you see here, we are going to design a diet, basically. And the way that this little drawing is going to become a diet is that each point of it corresponds to a diet. Each point right here corresponds to a diet with a little caveat that your daily diet is going to consist of bananas and oranges, and that's it. For this exercise, you're going to survive with only bananas and oranges. Everybody that has the app running, please say yes. I still have quite a few that are not. Very good. So if I think about the point B right here, then its x value is 45, that I'll understand as you're going to consume 45 bananas per day. And its y value, a bit hard to see, is 10, which means that you're going to consume 10 oranges per day. I thought that I corrected it. That should be the y value should be oranges, actually. Yeah. So the y value is a number of oranges per day. The x value is a number of bananas per day. And we will have some vitamins that will tell us if our diet is good enough or not. But at the moment, I want you to play with the 3 sliders that you have here at the top. So the uppermost one is tell me what's the budget, the daily budget that I'm planning to invest in my diet. The upper one tells me what is the budget that I'm going to spend per my diet. Let's say $57 per day. And the next 2 sliders control the cost of a banana and the cost of an orange. So right now, a bit hard to see. The cost of an orange is $1.5 and the cost of the banana is 2.4. Should all play with this. And now let's try to understand what this line that you see over here is telling you. So I'm taking, if every point over here in the page is represent to a diet that has an interesting day. Somebody wants a puppy? Okay. X is here, every point is a diet telling us how many oranges and how many bananas are we going to consume daily. And now I'm saying that I'm looking at all the points, X, Y, each one is a diet, such that X times the banana cost plus Y times orange cost, this number is exactly equal to our budget. Okay, so this line that you see right here is a line that I'm defining as by just writing this very same equation. Let's make it a bit larger. Okay, meaning that what happens if I move the budget? Of course, there are more diets that I can afford. Right? The gray area are all the diets. Every point in the brown area corresponds to a diet that I can afford, that is less than my daily budget. For example, 0, will mean that I don't need any bananas, I don't buy any oranges, so it costs me altogether 0. 1, 0 means I'm just buying 1 orange and no bananas, still under my budget, and so on. Being on the line exactly means that my budget is diets that consumed everything in my budget. Being below this line means these are diets that leaves you something from your budget to buy maybe other food. And notice that if I'll make banana more expensive, as I'm making banana more expensive, of course there are fewer bananas that I can afford. Being point on the x-axis means these are diets that consist only of bananas. Points on the y-axis are points that consist only of oranges, and if I'll make orange more expensive, there are fewer oranges that I can afford with the very same budget. But the one behavior, we will not be done with this today, of course, the one behavior that I want you all to notice is if I'm making the budget, if I'm adding value to the budget, what happened to the slope of this line? The slope, the angle that this line creates with the x-axis. Getting smaller or larger when I'm changing the budget. I mean, play with this, tell me what you're getting. The slope stays exactly the same when you're changing the budget. That is, the way that this line is moving, parallel to itself, and it's going to be quite useful for us later when we'll try to find the cheapest diet. Next, let's try to introduce the vitamin constraints. So the only thing that determines if our diet is healthy or not are only if we are getting all 4 vitamins A, B, C, and D. From vitamin A, I need to get every day at least 140 units. And I'll tell you that in orange is the x-axis, remember? In oranges, orange contains 3 units and banana contains 14 units. So how many units do I get from xy? If I have some x0, y0, how many units of vitamin A do I get? Help. Let's say if I got 2 oranges and 3 bananas, how many units of vitamin A do I get? That was not what I thought. It is trick question. It is if I have 2 oranges and 3 bananas, and every orange contains 3 units, every banana contains 14 units, then I'm looking at x number of oranges times 3 plus bananas y times 14. And to get the daily amount, what do I need to do? What do I require from x and y? That it should be smaller or equal than 140 units altogether per day, just for vitamin A. So let's write it down. Please write it down go to the text, and then in the left side of the screen, you can choose between graphic tools or calculator tools. Go to the calculator where you have set of horizontal line and write this equation: 3 times x plus 17 times y is less or equal. Less or equal, just type first smaller than and then equal. Less or equal than 140. Okay, which sorry, not smaller than. What do we say? You are not dying in this diet from too many vitamins. No. You have to get at least 140 units, so that whatever you're getting from oranges plus whatever you're getting then banana should be at least 140. Everybody has this pinkish, it might be different color, but everybody should. Okay, let's move to the next, to vitamin B. So vitamin B, you have 5 units in an orange, 14 units in banana, and you need at least 180. So similarly, I will write 5x plus 14y should be large or equal than 180. Okay, and play with this a bit, give it a different color, just so you can see it a bit differently. Or you don't. And now you should have 2 letters, one before the first inequality, one before the second inequality, and I want you to write, in my case there are B dots and C dots. In your case it might be different letters, but write the first letter, B in my case. Now write a ampersand. You know what you have above the 7, write ampersand twice. Write ampersand twice, then the and sign should appear, and C. And now I want you to, some new region is highlighted, and I want you to think about the 3 types of regions that we have here. We have the white region, which means you are not getting not enough vitamin A, not enough vitamin B. We have the blue region that says a diet from here, you're getting enough vitamin A but not enough vitamin B. The opposite over here. And now if I'll look at all the points that are both in B and in C, I'll turn down the, if you click the disks on the left, a lot of the other things vanish or appearing. What's happening here? This is a region in the intersection of both the constraints. A diet from this region is a diet at which you're getting both enough vitamin A and enough vitamin B. And if we are pretending that these are the only 2 constraints that we have, for the sake of time, now I can actually ask what is the cheapest diet that gives me enough much of vitamin A and vitamin B. I'll just go down with the price, and as long as I am in the positive part, probably this point, it belongs both to the vitamin A, both to the vitamin C, and I got to it by shifting the price until it almost vanished. That is, if I think about all the diets that I can afford, if I think about all the diets that I afford, this is this brown thing, it's accidental that they are both brown, these brown things are all the diets that I can afford. These big brown things are all the diets that are healthy, getting enough vitamin A, vitamin B. Points that are in the intersection means you can afford it and you're also getting enough vitamin A, vitamin B. So we'll add, next class we'll add a few more vitamins, and yeah, we'll see how from all of it we are getting into an algorithm that is extremely useful, extremely basic, called linear programming, which is one of the most powerful tool for optimization problems. Thanks. Sorry for the technical issues.